Yeah, so I guess it's been a long day. So there's been no code in this slide. And it's maybe not your average data science talk, but it's a bit different, so maybe that's interesting. So Python versus orangutan. Everybody knows this guy, right? His name is?
Wally.
You see, I always thought it was Wally, but you Google the picture, it's Waldo. Interesting. So where's Waldo? Yeah. Well, maybe. Anyway, so the whole point being, where's Waldo? So if anybody can see Waldo here, I'll eat my shoes. But yeah, he's right there. So, you got some character Waldo, you got these cluttered scene, and you have to kind of figure out where he is. That's kind of the game. So I was kind of faced with the same problem, but instead of Waldo, and instead of some kind of cartoon scene, I was faced with jungle and figure out where is the orangutan. Does anybody see the orangutan? Well, actually, there's none here, but you get the point. So just maybe a bit of background. Why am I talking about orangutans, or just maybe about me personally? My background, I come from a computer science, machine learning this kind of environment. However, I like physical, tangible things. I was more drawn towards big machines and engineering and aerospace and that kind of thing. But I like, given my background, I like to do something useful, lack of a better word, something useful, something that contributes something to society also. So I've done quite a bit of work in the humanitarian or conservation domain. And you bring these things together, robotics becomes an interesting topic because you can merge these three different things. Then again, some people may know me from the algorithms or the machine learning meetups, which I organize. Anyway, also just a personal pet project of mine at the moment is I'm trying to build a litter robot that can go clean up litter, but it's not easy. But if anybody is interested, I'd love to talk about this. And actually, all the stuff I'm doing now is, or I'm going to talk about today, is stuff I've done over the past year or so when I was working with a drone company. But now, actually, since 2 weeks, I've now switched hats, and now I'm working for Oxbotica, working on driverless cars and things. And maybe that's a talk for next year. But again, I'm always interested to talk to people if you want to chat about this. Anyway, orangutans. So, long story short, I've been working with International Animal Rescue, who are a fairly large animal rescue charity. And they work with a number of species, but in particular, they have a couple of large orangutan centers. And so orangutans are an endangered species. And there's a big issue with habitat destruction. So you have animals who have been found, who've been essentially chased out of the forest by palm oil plantations who were cutting down the forest to plant palm oil. Because they look so cute, people like keeping them as pets, but often tied to a chain for 10 years at a time. Or there's some sad stories there. And hence you have various charities like International Animal Rescue who try to take in animals that have been abused as pets or rescue them from palm oil plantation, etc. And then try to rehabilitate them as best they can and release them back into the wild. That's kind of the idea. But the problem is then, okay, fine, you've invested a whole bunch of time and a whole bunch of money, and it's shocking how much time and money goes into this, into rehabilitating a particular orangutan. And let's say the age is right and he's healthy enough, etc., you can release him back into the forest. But the whole point of releasing them back in the forest is that they survive, a full, healthy life. So they live up to their, the 40, 50 years or whatever. The problem is you release the orangutan. How do you know he survives 6 weeks, 2 months, 8 years? How do you know he's still around? How do you know he's doing all right? It's jungle. So this is a problem. How do you want to track the animal to actually check up on him and say, okay, is he doing all right? Okay, no, he seems to have some trouble. Let's take him back in or whatever. So this is the fundamental problem and what people refer to as the post-release monitoring phase. And so the overall goal is, you have an animal, you've released it, and you want to kind of monitor what the health and the well-being is of that particular animal. And this is very intensive. It's essentially 24/7 for the first 2-3 months, and this then tapers off over 2-3 years. Now, different charities manage this differently, but this is the case I was working with. So you can imagine for 2-3 months, 24/7, it's essentially you're trudging through the swamp and the forest, waving about mosquitoes and trying to find these animals. It's not fun. It's very human intensive, and also, okay, fine, you follow them 24/7 for 3 months, so you know where they are, but then you haven't seen them for a month or a week. Where is he? How do you find him? Not tricky. Now, so you need some kind of tracking system. And there's different elements to this. There's electronics, there's the actual tracking electronics. There's how do you somehow attach some kind of tracker to the animal. Then there's how do you collect the data, how do you transmit it, and then how do you interpret the data. And now, I don't have time to talk about everything, but these are the fundamental bits, and there's interrelated, and there's all kinds of trade-offs. It is worth thinking about attachment, though, because, often people say, well, this is a solved problem. If you're tracking elephant, or you're tracking rhino, or even pigeons, you can buy collars. You put a collar around the neck of a cheetah, or even little collars around pigeons' feet or things. The problem with orangutans is they're very clever, and they're very strong. And the physiology is such it's not obvious where you would attach anything. You think, okay, maybe put a collar around the neck. But the problem is, especially the males, they have these cheek pads. So, no, you can't put anything around the neck. It would obstruct with their physiology. That doesn't work. And also, they don't really have a neck. You could often probably just slide it over. Then you think like maybe an anklet or a bracelet. But again, they're very flexible hands. You just slide it straight off. And also, you'd want something that, you attach it, and the first thing it'll do, they'll start biting it, pulling it, and chewing it. And, again, they're very clever, and they're very strong. So this is actually a very tricky problem. Many people thought about for a long time, and it's not say it's impossible to attach something externally to an animal, to an orangutan, but it's not trivial in any case. And I'd love to hear suggestions. But anyway, so there's all kinds of trade-offs. You want something that's strong, but you also want something that adapts as the animal gains weight and loses weight, and there's all these kinds of conflicting trade-offs. But very interesting. But that's why actually at the moment what people use is implants. Ideally you have something externally, because that's nice and easy, but for the reasons I just mentioned, they use implants. And so these are, you can see them here. I actually forgot to bring some today, but they're about the size of a 50p coin, about 1 centimeter thick, and they're implanted at the back of the neck where the animal has a fatty patch. And these send out a VHF pulse, so a little radio pulse every 1.5 seconds, a very brief pulse. That's all it does at a particular frequency. And every animal operates at a different frequency. So these are implants. It's a bit of surgery, but it's not the end of the world. Battery life is up to 2-3 years if you're lucky. The problem is it is surgery, so it's the animal has to you have to sedate the animal, and then there's a healing process, etc. You can't charge the battery. They're actually quite unreliable for the amount of money you pay for them. But okay, that's the only technology there is. So okay, fine. You have these animals. You've got these implants. You put the implant back in the animal. You let the animal go in the forest, and then you need to follow him. You need to track the animal to see what it's doing. So it's a radio pulse. So you have an antenna, and you can pick up the pulse with the antenna. So what happens is there's two people. You wander through the bush, and you have your antenna, you have your headphones, and you kind of wave the antenna around. You listen for beep, beep. Okay, and the animal seems to be there, and you continue. The problem is the range you get is 200-300 meters. So if you're further away than 200-300 meters, you don't hear a thing. Good luck trying to find the animal if you haven't seen it for a month. And you don't really appreciate it until you've stood there up to your knees in the mud and the mosquitoes around your head. And if you think you have to go up and down this for a hill or through the jungle for literally weeks, just trying to figure out where on earth is the animal. Is quite frustrating. So okay, that's ground-based. So one idea is, could we do this from the air? Let's not whack our way through the bush. Can we somehow fly through the air and then listen for the signals and map out where the animal is? So that was this project all about. So can we use a drone to fly above the canopy, and with a suitable payload, we can listen for these radio pings, and then we can figure out where the animal is so that we roughly know its location, and then a ground team can go straight to where they need to be. And we save a lot of time whacking through the bush, waving antennas about. So that's the fundamental problem. Now this is, the pros and cons. Drones are good. They're relatively cheap. The technology is mature. You can't cover thousands of square kilometers, but you can cover a lot more than a human can do walking around. You can use them for multiple things. But of course, they do require maintenance. They do require some skill to operate and such. But okay, it's a useful trade-off. Then just a side note, because I often get so fed up with people when you mention this, and I'm doing a talk about this in a few months' time somewhere else, and the lady who's organizing this talk, she wanted to promote my talk, and she made this big headline, "Oh, drones and deep learning saving orangutans." No, the key thing to understand here, we're using drones, yes, but all we're doing is turning the needle in a haystack problem to a needle in a bale problem. We can search a larger area, but we still have to search. we're not solving the fundamental problem. The fundamental problem is these implants, which only have a range of 200 meters, only have a battery life of 2 years. There really needs to be a better solution. And that's actually something, a side project, we're kind of exploring how we can do maybe kind of a sensor network type approach, or we use more sophisticated implant technology or whatever. It's not the be-all, end-all solution. It's not going to save orangutans from extinction. But for this particular project and the partners we're working with, it makes sense to explore this. The core problem really is habitat destruction. Is just people chopping down forests, and there's all kinds of social issues, political issues that tie into that. It's quite complex, and it actually is pretty depressing if you're actually there and you see what happens. But okay, side note. Anyway, so the idea is we want to start simple. So the idea is, okay, we have some kind of unknown area. We set up a pre-programmed flight path, so a lawnmower pattern, shall we say. And what we want at the end is some kind of picture like this, where we have, okay, these are, we have, in this case, we've detected 4 different animals, and we know roughly where they are, and we can go find them. That's the idea. Now, the pros of this is fairly simple, and naturally we can do multiple animals. We're just going to fly a pre-programmed path. We just listen at different frequencies and see if we hear any beeps, and then we just generate a plot like that. The disadvantage is we're not very particularly efficient. You could be more clever, and you could say, well, let's use a very directional antenna. Let's go up, let's do 360, try to find a bearing on the signal, zoom in on the signal, and then continue our search. But this gets more complicated, and complicated is not good, definitely not in the jungle. But that's the idea. Okay, does that kind of make sense? Drone, fly above the canopy, listen for signals, generate heat map. So that was the idea. So I spent a lot of time thinking, okay, how do we do this? And again, starting simple with just off-the-shelf stuff. We start with a drone, multi-rotor, nothing special, just something where you can mount lots of things on. Pixhawk autopilot, which is a standard, one of the more popular DIY ones, pretty good. And then we have, so that's the drone itself. Then we have the payload. We have the transmitters here, which are implanted in the animal. Then we have an antenna. It's an RF, it's a radio signal. We need to receive the signal. And then we need something to turn this analog signal into a digital samples, should we say. We need to sample the radio signal so we can do some detection on top of that. And so this is done with a software-defined radio, which is a fairly standard thing. All it does is it listens for a particular frequency band, and it gives you digital samples of the radio signal in that band. And then we plug that into in this case, it's an Odroid, so just think of it as a Raspberry Pi, but more powerful. And then we, of course, run Python, otherwise I wouldn't be standing here. And we have a little web application sitting on top of that. So that's kind of the idea. This is sending out pings. These two are mounted on the drone. You'll receive the signal through the antenna. You do some processing on the onboard computer. And then you figure out, did I detect an animal or did I not detect an animal? And that's how you fly about. In terms of Python, it's nothing you wouldn't expect. So there's a nice library called DroneKit if you want to interface with an autopilot and know what its GPS location is or send it waypoints or etc. Nice high-level Python library. To interface with the SDR, the software-defined radio, there's again library library. All the processing is the usual scientific Python stack. So NumPy, SciPy, Matplotlib, GDAL is more for generate some geotiffs in the process. And then actually front-end stuff, well, all this is served via Flask, and then you have a nice little high-level web application that through a browser you can interact with the payload, and that's just on Leaflet React, just because it was convenient. So the whole idea being that, the purpose of building the system is we can then give it to the charity to operate, which means they have to be able to operate in a fairly easy, seamless way. So the idea being you just have a tablet and you say, look, I'm looking for this animal, this animal, this animal. They're operating these frequencies. Please search this area, hit go, and the drone goes off and it searches and does its thing. That's the idea. So, that was kind of the stack. And when I initially started this, it was like, okay, fine, I have a radio signal. And I can do a Fourier transform, and I look at the frequency spectrum, and I can try to look for spikes in the frequency spectrum, because a spike will mean a pulse, a strong pulse. So I can do that, and I spent some time looking at just various ways, looking at the distribution of the spectrum, and is there an easy way I can cluster the data into, where I have detections or where I don't have detections. But of course, that didn't really work out. There was no really easy way. So in the end, after lots and lots of testing, The general workflow that happened, that came together is this. So yeah, the interaction is through the browser, and so the drone takes off, and then it starts flying at a particular speed, a particular altitude, and then it runs through a continuous loop. And what happens in that loop is you listen for, let's say, 2 seconds. You just listen for a radio signal. You listen 2 seconds, you collect samples, then you take those samples and you do a Fourier transform and you look at the spectrum. And then the spectrum, you can see, is there a peak in the spectrum? There'll be a picture later to make it clear. Where you look at the peak, and if you detect a strong peak, that means, okay, there's a particular pulse. And if that pulse is at the frequency of the animal you're looking for, you're probably within range of the animal. Now that doesn't always work, so while I started off with that, sometimes the signal is too faint and you really can't pick it up from the spectrum. So you can do something in the time domain as well. It's a pulse at a particular frequency. What you can do is you can cross-correlate the pulse with the samples you get and to see if there's a high correlation. And then that gives you another heuristic for saying, okay, do I think there's an animal there or not? And all this happens offline, so there's no communication with the ground. The drone flies around and comes back and tells you what it's found. It's heuristic, it's not exact. There's issues with the implant is not the exact frequency it's supposed to be, and we need to operate in real time. So as we're flying about, we need to be in real time collecting everything. We can't have gaps because then we might miss things. Right, okay, I have to be conscious of time. So this is the kind of data you get back. You get a spectrum, so this is the frequency, and you just get the power at each particular frequency. And then you can take this, you smooth it a bit, and that's where you get this. This is the time domain stuff, let's ignore that. But essentially we're looking at this here, and is there a particular spike or pulse here? In this case, doesn't seem to be much going on. This is an example of a detection. So here you have a bump in the frequency spectrum, and if you smooth things out, actually you see a very clear peak. So this means yes, we've detected an animal at this particular frequency. Great, you log that with the GPS position of the drone, and you can continue. So, sorry? Is that a logarithmic or a linear? This is linear, and this has just been normalized, so that these things don't actually mean anything. It's still relative. Sorry.
Just about this graph, is it normal that the peak is so clearly visible, or how do you, because they're not small hills,
so
how do you decide at which point it counts?
This is where the heuristics come in. So, in this case, it's very obvious. You got one big peak and lots of small things. This one stands out pretty high. It's also, given the animal we're looking for, it's roughly in the right range. So I would be looking at this, I'd be 100% sure that, yes, that's an animal. Now, of course, as this is only half as big, and these ones are a bit higher, it's less obvious. So this is a great example, but it doesn't always look like this. And so that's why there's quite a few heuristics in there to look at the size of the peak relative to the others, what's the area, what's the magnitude, also look at in relative terms, but also in absolute terms, what the strength of the signal is, et cetera. And there's a combination of heuristics that together you figure out, is there something, yes or no? But you're going to make mistakes. And actually, I hope for the next iteration to do something Bayesian. I think was the Bayesian guy here from last talk? Yeah. I think it makes so much sense. I'd really like a Bayesian approach here. Anyway, conscious of time, because I'm going to get in trouble. But the very first thing we tested was just take a big antenna, strap it to a commercially available drone, and just see, does this work? Do we get any interference? Does it remotely even work? And actually, yeah. You collect some data, we put a few dots on the map. Okay, it was very, very rough, but the principle was proven. And so then I spent, pretty much 8 months on my knees in the mud in the New Forest, trying this, going through iterations, flying and testing, and wondering why stuff wasn't working, et cetera, et cetera. And then, the workflow kind of being take off autonomously. I'm just conscious of time, and then it's hard to see, but you see a tiny little dot. So this is starting very easy, very low. The transmitter is right here, the white thing, and then we start slowly at 10 meters, and we go up and down, up and down. And then we go progressively higher, and this was done eventually up to 120 meters height, fly up and down, and then see at what point do we stop receiving a signal? What's the maximum height I can fly at? What's the maximum speed I can fly at? So again, there's lots and lots and lots of tests throughout the winter. And then we come back to land. But the results were encouraging in that, think of just as a heat map. We got the star is the known location, and the heat map is my heuristic. And so we got a nice big, red blob around where the actual location is. So okay, things seem to be working, and this worked 10 meters all the way up to 100 meters. So okay, lots of tests were done. I think okay, this seems to be working. However, working in UK does not mean it'll work in Borneo. So that was the idea. So then we go to Borneo, and then we started doing the same tests there. Now, so this is the same copter. There's a square antenna strapped to the bottom, which you might see. So we take off. And this was filmed with another drone, actually, that they had on site. So it worked out quite well. Where's it gone? Oh, there we go. So go to a particular altitude. And then fly off and start doing a search pattern. And so while the thing is flying in, just listening for the radio signals, and then running the Python code on board to kind of process and figure out, is there a peak, yes or no, essentially. Yeah, so, and indeed, and this is also the first time we tested with the actual transmitters implanted, and again, actually, results were pretty good, and there were nice, strong peaks, so. But a lot of it depends on how high you are from the animal, and especially if you got lots of forest between you, that's going to attenuate the signal, etc. So while I was getting maybe, let's say, 100 meters in the UK, I was only getting 50, 60 meters in Borneo because of the environmental conditions in the canopy. But okay, we did lots of tests on the pre-release site, so they were animals, we knew where the location was, and I spent lots of time flying up and down, different height speeds, generating heat maps, and actually it worked quite well. So again, in this particular case, there's a very clear red hotspot around where the actual location is, and we verified that by actually going to the animal and taking the GPS locations. And so that all worked quite well. And so that was then kind of the second phase of the test. We've done it in the UK. We've done it on a testing site in Borneo. And this is actually what the user interface is what I put together. It still needs lots of work, but the basics were there. Again, you can tell tell which animals you're looking for, your settings of the radio. You do the flight, you come back, and you get an interface like this. And you can click on the map and zoom it around. You can idea, okay, where the animal is. So then we went to the actual release site, which was a long drive and a long hike away through horrendous conditions. But then, so this is the actual release site. So once the animals are really let go for good, this is where they're released. And so there's a camp in the middle of the jungle, and so this is where we're taking off and searching from. So in this case, we arrived at the camp, and we wanted to verify that everything worked. So the closest animal was about 2 kilometers away. So what we're doing here is we're flying up to a particular altitude, dashing out 2 kilometers, doing a search pattern, and coming back 2 kilometers, and then see, did we detect anything? But actually, doing just that was already quite tricky because trying to get a proper GPS lock underneath the canopy was very hard. So it was very hard to estimate our own height and the height of the animal, so to set a proper flight path. And then just the issues of the heat and the humidity with the Odroid cooking itself, the voltage regulator burning through, and all these kinds of issues when you actually try to do something properly. And because of failures in the hardware, this was done completely blind. So the thing would take off, it would go, and I would just have to cross my fingers and hope for it to come back. I had no telemetry whatsoever. So this was a very tense moment. So it goes off and does its thing, and then I was very happy at this point to see it come back. Oh yes, it came back. And then also became clear just operating this kind of environment is very difficult. Taking off is one thing, but landing through there, so the thing was 100 meters. I was trying to eyeball and trying to take it down, which in this case luckily was okay. But that's also raised issues in terms of what drone we're using. So far we've done everything with a copter, just because easy to test with, and you only need a small takeoff and landing space. The problem is the endurance you get with these things is nothing. So we'd like to go to a fixed wing, but then you need takeoff and landing space. We don't really have takeoff and landing space. So currently I have somebody working on a hybrid system, so maybe we can take off vertically and then fly with wings. So I was very relieved when that thing was back on the ground. So it landed, and then we all looked at the data, and this was the recorded video, and we said, okay, it looks good, and okay, how high are we? I wasn't sure how much clearance we had with the trees. And we got very excited, so okay, let's drop the height somewhat and do a larger search pattern, and off we went. And then again, it took off, it flew away. And again, waiting there 20 minutes, and then the only telemetry I had was the transmitter connection. That triggers again once it's within a range of 1 kilometer. So I triggered, so I knew it was about 1 kilometer away, and then suddenly everything went dark. So we were waiting there like 20 minutes, like, okay, maybe it's just the longer search pattern. 25 minutes, okay, let's look at half an hour. Oh crap, we probably lost the drone. And yeah, so it didn't come back. We did then a post-mortem and looked at the topography and things. And well, because we lowered the height everywhere, we didn't just lower the height on the search pattern. What happened was most likely, so it took off, it flew 2 kilometers, it did a search, fine, went and it came back. But on the last kilometer back, there was a hill with some pretty high trees where it hit one of the trees and it's stuck in a tree somewhere. But okay, at least we proved the concept and the data was collected. So anyway, so lessons learned from all of this, we proved the concept worked. We can get detections. We can do an aerial-based survey. Found that if it can break, it will. I've seen everything break and drones get destroyed and things. It's astonishing. You actually try to do something in the real world. I also find if you didn't test it, it probably won't work. I just even assume it doesn't work. And if you change something and you didn't test it, either it'll hopefully just not work or it'll break something else. It's a lot of procrastination. And generally, especially operating in that environment, robustness is everything. Simplicity and robustness is key. I prefer that much over having something that's very efficient and very fancy. As for the future, so I'm now working on phase 2. The aim is to go back by the end of the year with a better system, better drone. And there's, in parallel, some work going on. What can we do with the implants? Maybe there is some kind of external attachment, not sure. And there's some interest from different species as well where this could be useful. And yeah, just of course, this has been a lot of my spare time, but it's a big thank you to International Mammalian Rescue. Bristol Robotics Lab has been involved as well, and a whole bunch of other people. And just to say, I'm essentially doing this all my spare time because I think it's an interesting and fun project, and I've learned a great deal. But if people are interested in any level, hardware detection, web app, whatever, talk to me. There's also some really interesting data the biologists have about the orangutans, how they behave, what they feed on, how they move, etc. He's just sitting there, unique. And so this is just one thing that struck me through is when you're there and you talk to people, and it's actually quite depressing if you really think about how you manage the natural environment things. As one guy put it, he's a head of one of these large orangutan projects. He essentially said, look, conservation is creating hope where there is none. If you start to think about it, it's just you think about the bigger picture, you just almost give up and what's the point? But it's really quite shocking. But it's something to think about. Anyway, thank you very much.
Can we do a quick question and answer round for things?
So I got a quick technical question regarding the question of the dog.
Yeah.
Could you take inside data on a data which give you DTM, create a random DTM? I know it won't be big, but it will be 50 by 50 meters. Pick up the highest peak and use it to make sure that you give yourself 10 meters buffer.
Exactly.
It won't be accurate, but it will give you enough safety to pick up the mountains, hopefully.
Exactly. So that's something we're considering to do. But also, actually, for the first flight, I had thought about this, and I'd ordered a laser rangefinder and planned to do some terrain following. But because of issues with UPS and a mess up on their end, it never arrived on time, so I couldn't take it with me to Borneo. And well, hey, we lost the drone. But yeah, some kind of terrain following, or at least doing a pre-existing map. So you can know what the height of the trees are. Is you really need to.
Difficult in this area.
Sorry?
You don't have a good map in this area. I don't expect.
Existing?
Yeah.
Oh no, yeah,
So
existing.
the easiest way is just to take some inside data.
Yeah, exactly. So that's for round 2.
Yeah,
this research is really similar to, I don't know if you look at atomic force microscopy, the way they do raster scanning. So it's exactly like that, they do raster scanning like that. And something they found in research actually is that if you go to spirals, like a really spiral, you get more efficient. And also something you can do that could be really relatable is that, like you said, you can do a first scanning of the surface, like and then you could use some kind of controller to put that scanning of the first surface as the initial data, and then on top of that, to just get the variation on top of your initial data set. So, I don't know, maybe we can talk about it later. There's a lot of research on that in microscopy, actually.
Well, I totally wasn't aware of that. I know about the flight pattern. We've just used lawnmowers because that's easy and pre-programmed. I did think about spirals.
The accelerations are quite not harsh on the...
Exactly, and so battery-wise. But in terms of how to more optimally schedule a flight path, be interesting to hear.
What ideas or hypotheses do you have about that noise level varying?
So you mean in the spectrum? Well, when I tell this to people, the first thing they say, but that can't work because the drone has too much interference. It'll drown the signal. I found actually for the platform I was using, yes, there's noise, but it's, so that's background noise from the drone. I've tried it on different platforms, and sometimes you see higher or lower. So that's just the drone producing noise, and you have to think how do you mount things and better radio equipment to mitigate that. There's also just ambient RF noise, but of course in the middle of Borneo it's not going to be too much, I think. But I don't, and there's just the components I was using are not particularly high spec or something like the radios. There's some inherent noise in that. So, and actually I'm currently working with an RF engineering firm to help me to design it in a better noise-resistant way. But if you have a radio station operating close by on the similar frequency, forget it. You're not going to see anything. You're just going to see the radio station.
Have you considered nighttime?
What? Sorry? Nighttime flying. Yes, we did because. And also at night, I didn't know, orangutans, they build nests. So every night they climb a tree, top of the tree, and they build a nest and they sleep there. And every night they build a new nest. It's always at the top of the tree. So this is great, right? The top of the tree, there's no canopy, you fly over then. The two problems, one, the biologists don't like it because you're waking up the animal, it's noise and etc. Two, actually the transmitters are programmed to only work from 6 a.m. to 6 p.m. But okay, so maybe you fly around 4 or 5 p.m., but then you're disturbing them making the nest. But okay, we could get away with that, but that would help.
Is there, because my immediate thought when you're using helicopter drones was also like, are you going to disturb the animal? Has anybody thought about using like a more sort of airship style thing, have potentially much longer endurance, much less disturbance?
Yeah, so definitely a fixed wing, potentially. For endurance at least, potentially solar powered. In terms of lighter than air, so airship, the problem is wind. Now, okay, it's on the equator and actually there's very little wind, which is good, but still you need quite a big volume and then launching it, recovering it, and it'll get blown about, and so it's not obvious. But I did think about it.
Okay, thanks a lot for the amazing talk. I think we have to move to
Yeah.
other questions.
Thank you.
Later. Thanks a lot.